Hello, hello, hello! Welcome to Algebra 2 this morning. As you can see, we're trying something a little different here. Today, you're going to take notes from this video that I prepared the night before. But first things first, go ahead and copy down today's objective. That's all this good stuff right here. Copy down today's objective into your source book or your notes. Go ahead and take 30 seconds to finish that up. Start to wrap up. All right. Now, what we've been doing over the past week or two has been solving systems of linear equations. We've done it graphically. Okay? That means actually graphing the two lines we're thinking about and looking to see where exactly they intersect, what the coordinates of that point are. Now then we actually use substitution to solve systems of linear equations. And remember, that was when we solve for one of the equations, we solve one of the equations for one of the variables, plug whatever we get back into the other equation, solve for the remaining variable, and then plug that back in until we get an ordered pair or a set of coordinates for a point. Okay, you don't have to take this down. Today we're doing something slightly different and tends to be a big student favorite in terms of the ways for solving systems. It's BAM! Solving systems using elimination. Okay. Our goal here is to eliminate one of the variables by adding equations. Okay. Again, we're solving systems using elimination, and our goal here is to eliminate one of the variables by adding equations. I'm going to give you 30 seconds to copy this down. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Before we get started, though, let's get a quick little vocabulary review in, get your words right. First of all, we have constant. A constant is any term that has a number part but no variable part. Okay, it's any term, that has a number part but no variable part. You can see right here in this example, 3x squared plus 4x minus 7. This negative 7 is a constant. Okay, the 3 is not a constant because 3x squared has a variable part. The 4 is not a constant because 4x has a variable part, that x. But this negative 7, that's got no variable part, so it is a constant. Okay. A coefficient is when a term is the product of a number and a variable. The coefficient is the number part. Okay. When a term is the product of a number and a variable, the coefficient is the number part. All right, so the example here, same polynomial, 3x squared plus 4x minus 7. You can see that the number parts of the terms that have variables and a number, 3 and 4. Those are the coefficients. So if I asked you, what's the coefficient of x squared, you'd tell me 3. If I asked you what the coefficient of 4x is, you'd tell me, no, I actually want you to say it. What is it? Yeah, that's right. It's 4. It's 4. Now, is negative 7 a coefficient here? No. Negative 7 is not a coefficient. Negative 7 is a constant, just as we saw before. All right? Let me give you 30 seconds. Finish copying whatever you need. All right. Now, let's get back to today's main agenda, which is, as I said before, bam! Elimination. Solving systems using elimination. Once again, our goal is to eliminate one of the variables by adding equations. We're going to see how that works in just 1 second. Okay? So let's take a look at a sample problem. Here's the system we're going to solve first. You don't have to copy it down right now. We'll get it in a second. Okay? 3x plus y equals 5. 7x minus y equals 15. Now, you could solve this by substitution, and that's totally okay. But I want to teach you this other method because it can be really, really powerful. Here's the first step. You want to copy this down. The first step of the elimination method is to multiply one or both of the equations by a constant. Remember what a constant is. Check your notes. By a constant, so that for one of the variables, the coefficients differ only in sign. Okay? We want to multiply one or both of the equations by a constant, so that for one of the variables, the coefficients differ only in sign. Take 30 seconds, copy that down. All right. Again, we want to multiply one or both of the equations by a constant so that for one of the variables, the coefficients differ only in sign. Okay, now take a look at this example we were working a second ago. Okay. We have 3x plus y equals 5, and we have 7x minus y equals 15. Okay. Now what you can see here is that positive y and negative y, plus y and minus y, these differ only in sign. Okay? They don't have different coefficients other than that. If you see 3x and 7x, these have the same sign, but they differ in their actual coefficient as well. Okay? This is 3, this is 7. But positive y and negative y, they already differ only in sign. Okay? So if we take a look at our first step, the first step was to multiply one or both of the equations by a constant so that for one of the variables, the coefficients differed only in sign. We don't even have to do anything to this system because it came to us already like that. One of the variables has a coefficient that differs only in sign. That's positive y and negative y. So in this case, we can go right to the second step. And here's that second step. The second step of the elimination method is to add the revised equations from step 1. We're going to add the revised equations from step 1. Okay. When we combine like terms after adding those equations, we're going to see that one of the variables gets eliminated. And then we're going to solve for the remaining variable. Take 30 seconds, copy this down. That's awful. There you go. Okay, so let's go back to that first problem we looked at. 3x plus y equals 5, 7x minus y equals 15. Okay, well, our second step was to add the revised equations. Okay, so we got to add these two equations up. Let's go ahead and do it. We get 3x plus y equals 5, 7x minus y equals 15. When we add these up, let's see. 3x plus 7x, that gives us 10x. Positive y plus negative y, well, those will cancel out for us, so we get nothing from there. And 5 plus 15, that'll give us 20. Well, then it's just a matter of solving for x. So here we have 10 times x. We're multiplying x by 10. So we have to do the opposite of multiplying x by 10, which is dividing 10x by 10. And we'll do the same thing to the other side. On the left-hand side, we end up with just x. And on the right-hand side, we end up with 20 divided by 10, which is 2. Now we're ready for the third step of the elimination method. The third step of the elimination method should look pretty familiar. All we're going to do is substitute the value you got from step 2 into either of the original equations and solve for the other variable. We're going to substitute the value you got from step 2 into either of the original equations, and then we're going to solve for the other variable. So let's go ahead, take 30 seconds, copy this down, and then we'll move right into it. All right. Let's go back to that first problem we were working. Okay. We ended up with x equals 2. The last step is to take that x equals 2 and plug it back in to one of the original equations. So I'm going to use the first equation because that's what I feel like doing. So let's see. 3x plus y equals 5. That was the original equation. Now let's plug in x equals 2. So it becomes 3 times 2 plus y equals 5. 3 times 2 is, of course, 6 plus y equals 5. We'll continue right up here. 6 plus y equals 5. Okay, now to get this y alone, we got to deal with that 6. That means subtracting 6 from both sides. Okay. Well, what we're left with on the left-hand side is y, and on the right-hand side, 5 minus 6 is negative 1. So we ended up with x equals 2 and y equals negative 1. Okay, so the solution to this system is, and we're going to write our solution as a point, as an ordered pair, 2, negative 1. Okay, take 30 seconds if you were a little bit behind. Get that down. Okay, one of the key things to realize about this problem, about this system of equations, is that when we got the system, we already had one variable where its coefficients differed only in sign. So the coefficient of y is positive 1, and the coefficient of negative y is negative 1. Their coefficients differed only in sign, positive 1, negative 1. So we got to skip the first step of the elimination method. In the next problem we see, we're not going to get to do that. Let's take a look. Okay, so we want to solve this system via elimination. We have 3x minus 7y equals 10, and 6x minus 8y equals 8. We want to solve this by elimination. So again, the first step of the elimination method is to multiply one or both of the equations by a constant so that for one of the variables, the coefficients differ only in sign. So when I see this, here's what I look at. I look at, okay, well, let me see my x's. Okay, I have a 3x and a 6x. Okay, I also have negative 7y and negative 8y. Okay, well, look, if I multiply 3 If I multiply 3 by 2, I'll get 6. But I actually want them to differ in sign, so what I'm going to choose to do is multiply this equation by negative 2. Let's see how that works. So again, suppose I started with 3x minus 7y equals 10, and 6x minus 8y equals 8. I'll choose to multiply the second equation by a negative 2. I choose to multiply by negative 2. So that means negative 2 times 3x, negative 2 times 3x will give me negative 6x. Negative 2 times negative 7y will give me positive 14y. Okay, draw my equal sign. Negative 2 times 10 will be negative 20. My second equation, I'm just going to let it stand. Okay, I'm going to leave it the way it is. 6x minus 8y equals 8. Same as we got it. Okay, so now take a look at this. Remember, our goal of the first step of the elimination method was to multiply one or both of the equations so that for one of the variables, the coefficients differed only in sign. Do we have that here? Do we have a variable where the two coefficients differ only in sign? Yeah, I think the answer is definitely yes, if you see right here. We have negative 6x and positive 6x. Okay. So then we'll move on to the second step of the elimination method, which is to add the revised equations, to add these two equations together. Let's see what happens. Okay. Negative 6x and positive 6x, when we add those together, they're going to cancel out. Positive 14y minus 8y. Okay, well, let's see. 14 minus 8, that'll be 6y. Okay, and negative 20 plus 8, okay, well, that'll be negative 12. Now we have 6y equals negative 12. Then we have to solve for y. We'll do that by dividing both sides by 6. Y equals negative 12 divided by 6. That will give us negative 2. Okay. Now we're ready for step 3 of the elimination method. Step 3 of the elimination method is, of course, to take that y equals negative 2 and plug it right back in to one of the original equations. So let's go ahead and do it. This time, I'm going to choose to use, let's see, the second equation. Doesn't matter which one you pick. Okay, so let's see. 6x minus 8y equals 8. We'll plug in negative 2 for y. So that means 6x minus 8 times negative 2 equals 8. Okay, well, that becomes 6x. Negative 8 times negative 2 is positive 16 equals 8. Continue up here. 6x plus 16 equals 8. Just rewrite my equation. Now what I'm trying to do is get 6x by itself. So I'll subtract 16 from both sides. On the left-hand side, all I have left is 6x. And on the right-hand side, I have, let's see, negative 8. Okay. Now, I'm trying to get x by itself, so I have to divide both sides by 6. That means on the left I have x, and on the right I have negative 8 sixths. Well, think, is there a number that goes into both negative 8 and 6? Yeah, there is. It's 2. 2 times what gives you negative 8? The answer there is negative 4. 2 times what gives you 6. And the answer there is 3. Okay, the 2's will cancel out, and we're left with x equals negative 4/3. And once again, we state our solution as an ordered pair, as a set of coordinates. So our solution here is x was negative 4/3 and y was negative 2. That's our solution. Let's try another. Let's see. We want to solve this system of equations. 4x plus 3y equals negative 2, and x plus 5y equals negative 9. Okay. Remember, that first step is to multiply one or both of the equations by some constant so that one of the variables has two coefficients that differ only in sign. Now, the thing I love about this problem, boom, x all by itself, all by itself. Okay, when I see that, I just think that is a gold mine. Okay, that is a gold mine, because what that says to me is I can multiply this equation by whatever this is, but negative. So you see, in order for my x's to have the same coefficient but different signs, I'd have to multiply this whole equation by negative 4. And that's precisely what I'm going to do. That's precisely what I'm going to do. So let's see. First, we'll rewrite both of our equations. Let's see. 4x plus 3y equals negative 2. And x plus 5y equals negative 9. All right, now this time, I want to multiply this bottom equation by negative 4. So let's see. The top equation will stay the same. Okay, the top equation will stay 4x plus 3y equals negative 2. The bottom equation, though, changes. Negative 4 times x is negative 4x. Negative 4 times 5y is negative 20y. And negative 4 times negative 9, well, let's see. Negative 4 times negative 9, well, that'll be 36, if I'm not mistaken. Okay. The second step, again, is to add those two equations that we just got. So we'll add them up. 4x and negative 4x, those are going to cancel out. Okay, so we're done with those. 3y plus negative 20y. Okay, that's going to give us negative 17y. And let's see, negative 2 plus 36, that's the same thing as 36 minus 2. Well, that's 34. Now we've got a single variable here. Let's solve for it. We'll divide both sides by negative 17. Y equals, let's see, 34 divided by negative 17. If you want, you can use your calculator for that. Or if you know that 17 goes into 34 twice, you'll know that this is negative 2. If you want to see that on the calculator, here's what it would look like. 34 divided by negative 2. 34 divided by negative 17. My bad. Negative 2. Okay. Now we're ready for the last step. Last step is to take that y equals negative 2 and plug it right back in. So this time, let's plug it back in to the second equation. X plus 5y equals negative 9. Okay. We'll plug in negative 2 for y. X plus 5 times negative 2 equals negative 9. 5 times negative 2 is negative 10. So x minus 10 equals negative 9. Now we got to undo that minus 10. The way we do that is, of course, by adding 10 to both sides. On the left-hand side, where you have x, And on the right-hand side, we have equals -9 plus 10, so that's 1. That means that the solution to this system of equations is 1, -2. 1, -2. Take a second. In fact, take 30 of them. Copy down whatever you're missing. Okay. Let's deal with one more problem for right now. Let's see, I've got 3x plus 3y equals -15. 5x minus 9y equals 3. Now something should jump out at you immediately for solving this system. The thing that jumps out to me immediately is, look right here, this positive 3y and this negative 9y. Okay. What would we have to multiply this equation by, this first equation, in order to make it so that 3y and negative 9y had the same coefficient but different signs? Yep, we'd multiply it by positive 3, excuse me. So let's do it. 3x plus 3y equals -15. That's our first equation. 5x minus 9y equals 3. We'll multiply the first equation by 3. So we end up with, let's see, 3 times 3x is 9x. 3 times 3y is 9y. And 3 times -15 is -45. On the bottom, it stays the same. 5x minus 9y equals 3. Next up, add the two equations. Try that on your own. Here's what you got.
14x equals -42. coefficient with different signs. I think the easiest thing to do is to try to get 2 and 3 to become 6 and negative 6. Okay, so let's see. Let's start with 8x plus 2y equals 4, and minus 2x plus 3y equals 13. Now, if I wanted to get this 2y to become a 6y, what should I multiply this top equation by? Yep, I'm going to multiply this top equation by 3. 8x times 3 is 24x. 2y times 3 is 6y. And 4 times 3 is 12. Okay, so now the coefficient of y here is 6. Okay, let's see. What should I multiply this bottom equation by to make this coefficient of y equal to negative 6? Think about it for a second. We have 3y right now. What should we multiply it by to get it to become negative 6? Yep, the answer is negative 2. Okay, so negative 2 times negative 2x is going to give you positive 4x. Negative 2 times 3y will give you negative 6y. And negative 2 times 13 will give you negative 26. So let's go ahead, add these equations up. Let's see. Well, first off, we know our 6y and our negative 6y are going to cancel out. That's nice. 12 minus 26, you can use the calculator for that if you'd like. 12 minus 26, negative 14. 24x plus 4x, well, that's going to be 28x. To solve for x here, we'll divide both sides by 28. Left side, we have x. Negative 14 divided by 28. Well, we'll leave it as a fraction. Then we think, are there any numbers that go into both negative 14 and 28? And the answer is, of course, yes. For instance, 7 goes into both of these numbers. So 7 times what gives you negative 14? Negative 2. And 7 times what gives you 28? 4. Okay, well look, 7's cancel. That leaves us with negative 2 fourths. We're not done yet. Are there any numbers that go into negative 2 and 4? Of course, there's 2. 2 times something gives me negative 2. Well, that's negative 1. 2 times something gives me 4. Well, that's 2. So 2's cancel. This is negative 1/2. That's what x equals. Negative 1/2. Now we can take that and plug it right back in to one of the original equations. So let's see. 8x plus 2y equals 4. Plug negative 1/2 in for x. 8 times negative 1/2 plus 2y equals 4. Okay, well, we can write that in a neater way. 8 over 1 times negative 1 over 2 plus 2y equals 4. Well, 8 times negative 1 is negative 8. 1 times 2 is 2. Plus 2y equals 4. Okay, well, negative 8 divided by 2, that's negative 4. Okay, negative 4 plus 2y equals 4. We'll add 4 to both sides. 2y equals 8. Continue it right here. 2y equals 8. Divide both sides by 2, and y equals 4. So the solution to this system of equations was x is negative 1/2, y equals 4. Okay. You can see the thing we did differently here is instead of multiplying just one of the equations, we chose to multiply both of the equations.
so that they would have the same coefficient for one of the variables, just different signs. One positive, one negative. Okay? This is the elimination method. So go ahead, finish copying this one down, then get going on your problem set. All right, let's get moving.